Alright, number 5. Determine whether the measurements A equals 20, B equals 15, and angle A equals 40 degrees produces one triangle, two triangles, or no triangles. So here, let's go ahead and sketch out a diagram just to see what this looks like. We know that little a and little b represent side lengths, and capital A represents an angle. So this is what we've got. We've got a side, angle, side, triangle. And well, I don't know what I'm doing right there. I was like, side, angle, side, that's not right. We've got a triangle that's side, side, angle. So we've got a known ratio, and we can start there. Now all it says is, does it produce one triangle, two triangles, or no triangle? So we just have to work it as far as we answer that question, because it's not going to be checking for all of our answers. But we have a known ratio, so I'm going to go ahead and set that up. And I'm going to have to look for angle B. And I'm going to have to do some calculating here. So I'm going to cross multiply and divide. So I'm going to end up with 15 sine of 40 over 20 equal the sine of B. And remember, we have to get B by itself, so don't just type this in. We have to do inverse sine of all this. And I'm going to be lazy because I'm short on time and just do that and type it in. And I've got inverse sine of 15 sine of 40 divided by 20. And I end up with 28.8. Since this is an angle, I'm going to round to 29. So angle B sub 1 is approximately 29 degrees. So at this point, I can see that I'm going to have to look for a B sub 2 in the second quadrant. And so I'm going to do 180 minus 29, and I'm going to end up with 151. So now what I have to do is check, is it possible for angle B and angle A to be in a triangle together? And it's not. If I do 180 minus 151 minus 40, I'm going to get a negative. So that means there's only one triangle. So one triangle, and then you would put some kind of explanation, really short, about this. Okay, it could just be as simple as angle A and angle B sub 2 cannot exist in a triangle together. Done.